Hello friends, in today's Architect Interview Question Series by Knowledge Powerhouse, we are covering another good topic, and this topic is what is dependency injection? Also the short form is DI. So what is dependency injection? Let's understand why do we use it and what is behind that, how we can implement it. It's a good thing that is being asked in many interviews, and you have to show your knowledge of this topic so that you can say that you are like senior engineer, you are principal engineer, and you can say that like what are the benefits of this mechanism. Let's see. So dependency injection is an important concept in software architecture, and it's a technique for implementing inversion of control. So inversion of control is a pattern in software architecture, and that pattern says like we should have custom written portions of a computer program receive the flow from a generic framework. So let's understand what is inversion of control. And also inversion of control is in solid principles of design. If you remember, I stands for inversion of control. So inversion of control means like traditionally you write your custom code. Let's say you have to like transfer some money from account A to account B. So what you do is that you write a custom code that get the balance of account A, subtract the money from account A, then add money to account B, like right. So all that is generic code. So you call the generic code from the custom code, right? Getting the balance, like incrementing the balance, all these are generic code, but the combination of that is your custom code. Whereas in IOC programming, inversion of control, the framework will call the custom code, right? So framework has the responsibility of calling the custom code and the generic code, right? That way, what will happen is that control has gone from custom code to the framework. So what happens is that if we use inversion of control, we are decoupling the execution of a task from the implementation. Also, the module can focus on the task that is designed for rather than like creation of like, getting balances, incrementing balances. And this will also free the module from any assumptions about how other systems have to work. And it will only rely on the contracts. It will just deal with the interfaces and work on that. And that will also help in reducing any side effects when we replace the module. Let's understand dependency injection by this diagram first. In this diagram, if you see, there's a client and then there's an injector, which is your framework. Now, client has to access service A and service B. Now, service A and service B are just like interfaces. And client is not creating these interface like these actual implementation of these, whereas injector creates the real instance of service A and service B and injects into client. That way, client gets service A and service B's actual implementation. Once client has it, then it can start invoking any methods on these services. If you see the sequence diagram, again here, first injector starts, then you have a service A instance, service B instance, and then this will be injected into the client, and then client can start working on these two services. So client doesn't need to know how these services are created, which means client code is independent of how the objects are created. So the concrete classes creation is the task of injector. So in simple terms, if a client wants to call a method on an object, then it should not worry about how to create that object. The creation of object is the responsibility of framework. So one of the popular, like another part I would say is that if we want to, let's say, get the current time from a service, then we just need to call that service rather than start creating a service to get the time. And if that service is not created, then the central component injector will create the service and provide it to the client. And that way, injector will inject the service into the client, and client will just have to call the service. So it doesn't need to have any logic to create the new service. So in dependency injection code, most of the time you will not see anything like new. So like in Java, we have a new to create an object that will not be there in the dependency injection code. One of the popular example of dependency injection is Spring Framework. So in this, all the logic of creating a new service is known to Spring Framework. So all the beans are created in Spring Framework, and Spring Framework will check if there is a services instance is present or not. If it is not, then it will instantiate that instance and provide it to the client. So that way, the clients do not have to deal with the creation of any beans. The main benefit of this is in separating the responsibility of using a service from the responsibility of creating a service. So you want to use a service, not start creating it, right? So that way the clients are only responsible for using, and like two separate developers can work on it. One is developing the beans, another is developing the custom logic to use those beans. So that way those concerns are separated. And the main intention of this injection, as I mentioned, is the separation of concerns, which means like if you are, let's say, expert in creating some kind of a calculator, so you focus on creating the calculator. And if you're expert in creating some kind of financial system by using that calculator, you focus on that financial system. You don't start implementing the calculator. And when both of the persons have done their work, then it can be integrated by using those interfaces, right? So that way the separation of concern is maintained between the construction and use of objects. Now, DI also helps in increasing the readability of the code. That is another side effect of DI, and because of that, maintainability is also there. Because if you are having two separate, like, things, one is for bean, other is for the custom code, so in future if there is a bug, we can know whether the bug is in the bean creation or it is in the custom code, right? That way we can easily identify and maintain the software in the long run. Another part of DI is that it helps in maintaining the promoting the code reusability. Like if we have like different entities that are implemented as beans or services, those can be reused multiple times as independent entities by the custom code. And you can like see that they are working in multiple scenarios. Going back to the example of calculator, so you have a calculator, now you can use it in financial software, you can use it in tax software, you can use it in billing software. So in all those kind of scenarios, you can use it by like reusing it again and again. So now let's understand what are the mechanisms of implementing dependency injection. So there are three major techniques of implementing dependency injection, and these are like, I'll just give you example from Java perspective, but in similar way you can implement in any other object-oriented scenario also. So these three techniques are construction injection and setter method injection and interface injection. So these three are very specific to Java, and but in programming languages also you can use them. So in constructor injection, what we do is that we have the constructor of a class. This client class is getting created. At that time, we just pass the service object. So there is no new service that is being created. When you're creating a client object, then you're passing a service object also. And who creates the service object? Injector. Injector is the framework. So basically, framework is creating the client, framework is creating the service. So the client doesn't need to know how to create the service. And at the time of constructor, it is getting created as a parameter to the constructor of this class. Another way is setter method, which is like if you have already created a client, now at specific point of time in your custom code you need a service, then what you can do is that you can just use a setter method that you say set service, and in set service again an instance of the service is being passed. In this case, there is no need for client to again create a service. It is expecting that before doing any work, I need that service. So like again, going back to the calculator example, if you want to calculate some kind of a invoice or billing thing, then first you do is you set the calculator as a calculator service, and then using that calculator, you can start calculating the tax, you can calculate like what are the total charges, and you can come up to the total amount. And last but not the least, we have interface injection. Here, if we have a service setter kind of a thing, interface, that interface can also like provide the service to client. So all the client has to do is they can just implement that interface. And because they're implementing the service, the interface, they will get the set service method from the interface, and there you can override to get this from the injector, which is the framework, right? So it means that it can be used to establish how the injector should talk to the client when injecting dependencies, right? So basically using that interface, client will get this kind of a dependency from the framework. So remember, what are the three techniques? Interface injection, setter method injection, and constructor injection. These are the three techniques of dependency injection. That's all on this topic from us, and if you have any feedback or if you want to cover any other question or topic, do let us know in comment. We'll be happy to create some video or lecture on that. Thank you and have a great day.